All right, so we're trying to find the complete solution to minus one, or sorry, 1 minus 1 x equals 2, 2. So, hot question. How do you know you can even do this? That question even makes sense?
It's a 2 by 2 mapping to a 2 by 1.
Okay, so at least the sizes are right. That's a good start, at least. Another thing I might check is like, okay, so in order for this to work, this x is, where does that x live? I'm applying the function to it, right? So this here x lives where? Give you a clue. It's either on the left side of the arrow or on the right side of the arrow. This thing here is the arrow. So is this a thing that's getting this function done to it? Or is this a thing that's already had this function done to it? In other words, is x in the domain or the range? Well, domain or the codomain.
Domain.
Good. X is in the domain. Now, in order for me to solve this, I would need this thing to be in the range. You guys see that? If it's not in the range, I can't solve this. Just won't have a solution. But if it is in the range, then I can solve this. So I need to know that this thing here is in the column space, right? Oh, look, it's twice this first column. It must be in the column space. You guys see that? That also lets me kind of eyeball the solution, right? I know that I can get a particular solution right off the bat by just saying, well, hey, it's twice that first column. You can augment this and solve that way. That's totally fine. You'll get this exact same thing, right? You guys with me on that? I'm just a little shy on time, so I just skipped there. What did we find for the null space for this thing before? You guys remember? It's the span of something?
1, 1.
Good, it was the span of 1, 1. I could eyeball that too by noticing that it's got to be perpendicular to the rows, right? You guys see that? In order for something to be in the null space, it's got to be perpendicular to the rows. Because the way I calculate it, right, is I take all those dot products. Crazy. Don't worry, we'll talk more about that connection later. So here I've got my particular solution and my null solution, or my null space. So what's my total x? What's my total solution here?
2, 0 plus C1 of 1, 1.
Perfect. Yep. It's the particular vector I found, direct summed, right? Mega plus the column space. And in this case, the column space is just that one-dimensional thing, so it's C1 times that. Notice if C1 is 0, this gives me back my particular solution. Right? And if C1 is anything else, then C1, 1, 1 goes to 0 anyways, and so I get back this kind of vector I started with, this 2, 2. Any questions on this?
Does the null space have anything to do with y homogeneous?
Oh, from differential equations?
Yeah.
Kinda. Yeah, we'll get there. That's a good, yeah, that's a really good thing to notice, right? Because what we're really looking at, right, is we're looking at equations like ax equals 0. And in differential equations, we're kind of thinking about, we might think about this as like some coefficients, and then we might think about this as like some set of derivatives. Yeah, that'll be there. We'll get there. Good eye. In case that didn't make any sense, don't worry about it. Take differential equations. It's cool. All right. Any other questions on this? Are you guys ready to go out and find complete solutions now?
Yep.
Okay, cool. Have fun. Kick ass. Thank you guys for coming to Zoom class today. I very much appreciate it.
See ya.